Okay, so now we're going to start doing the assignment problems. So if A is equal to this, and B is equal to this, and C is equal to this, we're going to write this in modulus argument form. So to write this in modulus argument form, so first for A, we need to figure out the modulus. So we've got 1 squared plus square root of 3 squared. So that's going to give me square root of 1 plus 3, which is the square root of 4, which is 2. So there's our modulus. And to figure out our angle, we're going to we go over 1, we go up radical 3. So radical 3, we go over 1. This is opposite, this is adjacent. So we've got tangent of our angle is equal to opposite over adjacent, square root of 3 over 1. And using this relationship that they've given us here, we know that the angle, the argument is pi over 3. So for A, we know our modulus is 2. And if we're writing our complex number in polar form, we need to remember that z is equal to the modulus times cis and the argument. So we know that for complex number 1 plus square root of 3i, we're going to have 2 cis pi over 3. Okay, let's find B now. B is equal to, so we need to find our modulus. So we've got negative 1 squared plus 1 squared. So this is equal to the square root of 2. And for the angle, we go negative 1 and up 1. Oops. So negative 1, up 1, it goes right there. So we need this angle right here. So we know this angle here is pi over 4. So this value here is going to be, so the argument of B is going to be equal to pi minus the blue part, which is pi over 4. Right? Because we're trying to figure out the green part. So we do the whole pi minus pi over 4, and so the argument is going to be 3 pi over 4. And then, so if I'm going to write the complex answer in polar form, we get our modulus is square root of 2. Cis 3 pi over 4. Okay. And for C, okay, so we need the modulus of C. It looks like K, doesn't it? the modulus of c is going to be square root of 3 squared plus negative 1 squared, which is going to give me 3 plus 1, which is square root of 4, which is 2. So my modulus is 2. Okay, and then I'm going to go over square root of 3 in the real direction and down 1. We're trying to figure out that angle. So this is adjacent, this is opposite. I'm going to say tangent theta equals opposite over adjacent, so 1 over square root of 3. So we know that 1 over square root of 3 is going to give me pi over 6. So we know that, oh, let's use a different color. We know that this angle equals pi over 6, but it's going down, isn't it? So it's going to be negative pi over 6. So if I'm going to write it in polar form, we know that complex number c is going to be equal to the modulus of 2 cis negative pi over 6. Okay, so now we've got our equations written in polar form. Okay, and this is exactly what we did in the H8F.1 Revision Village handout. If you haven't done this, then you're not going to understand what we're doing. You need to do this assignment. Okay, so now I'm going to take these answers here and I'm going to multiply and divide these complex numbers. So if I've got 2, so if I'm going to, what we learned from here is if I've got this times this, we're going to multiply the moduli and add the arguments. So I've got 2 times 2 cis pi over 3 plus negative pi over 6. So that's going to give me 4 cis 2 pi over 6 plus negative pi over 3. All right, I just made got a common denominator, and so I end up with 4 cis 2 pi over 6 minus, oops, what am I doing? It's going to give me pi over 6. Okay. Did I make a mistake? Okay. Okay. No, I didn't. Okay, good. And then for this, I've got sorry about that. I just needed to check this answer, make sure I did that right. And I believe I did. Okay. Okay, write it in Cartesian form. Before we can write it in Cartesian form, we first need to multiply in cis form. So what we did on this assignment here, we learned that we cannot, it's very difficult to multiply, divide, or put things to the power in Cartesian form first. So we first have to do it in polar or Euler form first, and then convert to Cartesian form. So to put this to Cartesian form, what we're going to do is what we did with this assignment here, and we know that we can rewrite cis theta as cosine theta plus sine I theta. So now we've got for cosine pi over 6 plus 4 sine pi over 6i. So actually, let's just write it like this first. Okay, so I'm replacing cis pi over 6 with cosine pi over 6 I sine pi over 6. And then now I can do distributive property like I was about to do. And I end up with 4 cosine pi over 6 plus I 4 sine pi over 6. Okay, and in the textbook, let's use our unit circle. Pi over 6 is cosine pi over 6 is radical 3 over 2. So I'm going to have 4 times radical 3 over 2 plus I 4 times sine pi over 6 is 1/2. And so that's going to simplify to 2 radical 3 plus 4 times 1/2 is going to give me 2i. Okay, good. I did this correctly. Woo! All right, so a divided by c, what we did with this other assignment, when you're doing division, you're going to divide the moduli and subtract the arguments. So this is going to be equal to 2 divided by 2. Right, those are my moduli. So 2 divided by 2, and cis, and I'm going to subtract the arguments. So pi over 3 minus at negative pi over 6. Okay. So and then I'm going to have 1 cis. We need a common denominator, so I'm going to have 2 pi over 6, and minus negative, let's change that to plus pi over 6, and then we're going to end up with 1 cis 3 pi over 6, which simplifies to I'm going to keep the 1 there. 1 cis pi over 2. Okay, now if I want to convert to Cartesian form, once again, I'm going to take this relationship here. I'm going to replace cis theta with cosine theta sine theta I. So I'm replacing cis pi over 2 with cosine pi over 2 plus I sine pi over 2. I did that substitution with those things. And then if I go to my unit circle, cosine pi over 2 is 0, and sine pi over 2 is 1. So this is going to be equal to 0 plus I times 1. Okay, well, that's just simply I. Okay. B to the power of 4. Okay, so function B, so we've got square root of 2 to the 4th power. Let's see if I've got it in polar form. You're going to, if it's to the 4th power, basically you're going to have your modulus to the 4th power, and then your argument you're going to multiply by 4. So I've got my modulus to the 4th power, and cis, the argument is 3 pi over 4, so 3 pi over 4, and then times 4. Well, that's convenient, isn't it? So then I am going to end up with square root of 2 to the 4th power is going to give me 4. For those who don't believe me, sure, let's square root of 2 to the power, oops, to the power of 4. It's going to give me 4. Right? So, and then we're going to have cis 3 pi. Okay, so now we're going to convert to Cartesian form. So to convert to Cartesian form, I'm going to have 4 cosine 3 pi plus I sine 3 pi. Now if I look at my unit circle, 3 pi, so here's 0, pi, 2 pi, 3 pi puts me here. So cosine of 3 pi is -1, and sine of 3 pi is 0. So cosine of 3 pi is -1, and sine of 3 pi is 0. Okay, so cosine of 3 pi is -1, sine of 3 pi is 0, so we're going to end up with our final answer is -4. Okay. I hope this is making sense. Okay, so a to the power of 3, b to the power of 2, same process. Let's keep on doing this. So a is 2 cis, okay, 2 cubed cis pi over 3 times 3 times, divided by b squared, so b squared, square root of 2 squared, so a, modulus of 2, and we're going to cube that. B, modulus of square root of 2, and we're going to square that. Okay. We're going to have cis pi over 3 times 3, and minus the cis 3 pi over 4, and then since it's squared, so we're going to multiply that by 2. Okay, so now we end up with 2 cubed, which is 8, and square root of 2 squared is going to give me 2. cis. Pi over 3 times 3 is going to give me pi. Negative 3 pi over 4 times 2 is going to give me negative 3 pi over 2. So pi minus 3 pi over 2 is going to give me, okay, well 8 divided by 2 is going to give me 4. And pi minus 3 pi over 2 is going to give me pi minus 3 pi over 2. So here's pi over 2, 2 pi over 2, 3 pi over 2 takes me to here, which is 0 and negative 1. So So pi minus 3 pi over 2 is going to give me negative pi over 2. Let's just write it as negative pi over 2. Okay. Because pi minus 3 pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2. So 3 pi over 2, which is the same thing as negative pi over 2. Okay, so now I'm going to write this as 4 times cosine pi over 2 plus I sine pi over 2. And then we get 0. Cosine pi over 2 is negative pi over 2 is 0. Sine of negative pi over 2 is negative 1. So this is 0 plus I times negative 1. And then we simplify that, and we're going to get negative 4I. Okay, last one. Oh my gosh. All right. A squared B C squared. So A modulus is 2 squared. B square root of 2. C modulus is 2. Okay, so I've got the modulus of A squared, the modulus of B, and the modulus of C, C squared. Okay. Cis. Okay, so I'm going to take pi over 3 times 2 plus, okay, the argument of B is 3 pi over 4, and then minus the argument of C is negative pi over 6, and since it's squared, it's times 2. Okay, so let's simplify these arguments. Well, let's simplify this. Okay, 2 squared divided by 2 squared is going to simply be square root of 2 left over. Okay, and then here I've got 2 pi over 3 plus 3 pi over 4 minus 2 pi over 6 simplifies to pi over 3. Okay, we need a common denominator, so I'm going to write this as over 12. So okay, so it's going to be 8 pi over 12 plus, this is going to be 9 pi over 12, and this is going to be 4 pi over 12. So 8 plus 9 is 17, and 17 minus 4 is going to give me 13. So I'm going to end up with square root of 2 cis 13 pi over 12. Yikes. I may have made a mistake somewhere, but I hope you guys get the idea. I'm not sure if this is quite right. Let's do the next part here. I just want to show you the answers for question 3. So write the number square root of 2 plus square root of 2i in exponential form. So first I figure out the modulus, and then I figured out the angle is pi over 4. So now it's in exponential form. We've got our argument, and we've got our modulus of 2. Okay. Okay, draw points 3 and 3i on the Argand diagram. So 3 plus 3i gets me right there. Okay, so this angle from here is going to give me pi over 4, and this length here is going to give me an argument of about 4.2. Okay. Without calculating values, plot these things. So, so 3 plus square root of 2 is going to give me a u value up here, and 3i plus, so notice the 3 plus 3 radical 2 is in my x direction, and 3 radical 2 is in my y direction. So it's going to be a straight line with that guy. When I multiply these together, I end up with, well, we know that this is multiplying. So I'm going to take the arguments of up here and here. So 2 times 4.2 is going to give me our new modulus of 8.4. And I'm going to take the arguments of pi over 4 and pi over 4, and I'm going to add those together since this is multiplication. And so now I can, I know my modulus is 8.4, and pi over 2 means I'm just going straight up, and 8.4 is somewhere up here. Okay, and then this divided by this, so I'm going to have the moduli divided by each other. So 2 divided by 4.2, sorry, 4.2 divided by 2, and so that gets me a modulus length of that. And if I subtract the 2, pi over 4 minus pi over 4, that's going to give me 0. So that means I'm just going to be going in the x direction this way. So there's with that length. Okay. So describe the geometric transformation that will take this onto uv. So so to u, I just added things together. There was no rotation. with the modulus and multiplying things together, the argument rotated to pi over 2, and we multiplied our moduli together. And to get to s, we divided the moduli, and then we also subtracted the arguments from each other. Okay, I hope that helps, and good luck on the assignment.